Welcome to EPA's Air Pollution Distance Learning Network. I'm Jan Cortelyou with the Policy Analysis and Communications staff for the Office of Air Quality Planning and Standards. I'll be your host for today's broadcast, Air Quality Data and Tools for the Ozone Season and Beyond. Air quality is a year-round concern for all of us, but in summer and in many communities, the ozone season is of particular concern. In today's broadcast, we will update you on the most recent trends in air quality and introduce you to some new tools and resources. I hope you will find them useful. I encourage you to visit the different websites you'll see listed during the broadcast and hope you will share them with other air quality professionals in your organization. There has been tremendous improvement in air quality in this country since 1990. Despite our progress toward cleaner air, in 2006, more than 103 million people lived in counties where monitored air quality was unhealthy at times because of high levels of at least one criteria air pollutant. Even after decades of regulation and emissions control, some air quality problems persist. Ozone and particulate matter are the criteria pollutants most often found at levels above national health-based standards. As EPA and state regulations come online, it's important to evaluate how these rules have affected the nation's air quality. Let's join Ellen Baldridge with the Air Quality Assessment Division to get an update on the most recent air quality trends.
Well, the Environmental Protection Agency maintains an air trend site. We update it every year with the current air quality status and trends information. There are 6 principal pollutants that the agency has set a national standard for, and those are carbon monoxide, lead, nitrogen dioxide, sulfur dioxide, ozone, and particle pollution. We monitor and track these pollutants and their levels from year to year. We look to see how they're changing from year to year. And then we also look at the emissions and particular emission sources that are emitting those types of pollutants. We look at how the emissions are changing from year to year. The purpose of this website is to actually provide updated information on how air quality is changing across the country. On the website, you'll be able to see national and local trends. You'll see trends for the last 10 or 20 years for the 6 principal pollutants. When you look at the standard and you look at the trend across the country, you'll see there's a spread. The national average may be dropping, but there's other constant sites that are still well above the standard and some that are well below the standard. So you always have that question, well, what's the air quality in my area? You know, it's one thing to say what the country is doing on average, but a lot of time what people want to know is what's happening in their own backyard. So there is the option to actually go in and select your state. It'll come up with state boundaries with little dots on it, and you can pick the dot that's in your neighborhood and drill right in and see what the air quality and how that particular pollutant is changing from year to year for that specific site. Right now, in the summertime, one of the key pollutants of interest is ozone. And part of that's because ozone is formed, or it's more readily formed when you have hot, sunny days and the air mass is stagnant. So here during this is the ozone season, the summertime. And so we look specifically at an ozone season average to see how ozone has changed from year to year. So a lot of times in your trend plots, what you'll see is a change in an ozone season average concentration. Now, one of the things that we do when we go to look at ozone more carefully to try to determine what's causing it to be formed and what can we do to control it, in other words, reduce ozone levels, what we need to do is we be able to remove the influence that weather conditions are having. So one of the things you'll find on our website is we've actually gone in there and we've taken that trend in seasonal ozone and we've adjusted it through a statistical method that we apply to determine how or what the ozone would have been under more typical weather conditions. That's the trend line that we use to associate with changes in emissions. So as we see our control programs coming in and being implemented and we see major emission sources being reduced, after we adjust for meteorology, we can actually begin to see a relationship between changes in ozone and changes in emissions. So one of the other things you'll find on the website is information in regard to an area and its air quality in relationship to national air quality standards. The agency sets standards that are set to protect the public health and the environment. These areas that get determined, we look at the air quality that's observed, and if the values are above the health standard, they get sort of tagged and they have special attention. The agency works in partnership with states, industry, and other regulatory agencies to try to target those areas for controls in which we can remove the emissions that are causing the air pollutant problem of concern and bring the area down to below the level of the national standard. For example, since 1980, the national average is down 21% for ozone, 41% for nitrogen dioxide, 66% for sulfur dioxide, 74% for carbon monoxide, and 95% for lead. And fine particle pollution is down 15% from the measurements collected in 1999 at EPA's national network sites. Also, even as the gross domestic product has increased, as vehicle miles traveled have increased and there's just more cars on the highway, energy consumption is going up and the population is increasing. In light of all these increases, the total emissions are coming down and air quality is improving. So 2006 is a success story. Okay, on the website you'll also find some key reports. There are updated trends reports that summarize our air quality trends and how they've changed from year to year. Those reports we pretty much update each year. But then there's some special study reports. And in this case, the one I want to highlight today is the NOx report. The NOx SIP call was implemented in the year 2003 and 2004. And if you look at the national average for ozone, you'll see that right there after 2002, for the first time, the national average for ozone dropped below the standard. And it hasn't gone back up. This current NOx report, it actually shows as the nitrogen oxides was removed from the air in the eastern part of the country, in large regions, so eastern, almost everything east of the Mississippi, you also saw in that same time period large reductions in ozone throughout the region. Right now, currently this year, the agency is looking at updating these reports, these trends reports, to contain a summary of how air pollution throughout the United States has been changing for all 6 of our principal pollutants for the last 10 or 20 years. We'll summarize how air quality has been changing. We'll also provide information on how emissions are changing in that same time period. And we'll provide information on the current status of our worst problem areas, the areas that the agency currently has designated as non-attainment. And you'll be able to see, or we'll show people in this report how those areas that used to be non-attainment, which ones are now in attainment. So there's been a lot of progress in our worst areas. Now, there are a couple of other programs that the agency is involved in. One is acid rain. Acid rain is covered in the report, and we'll talk a little bit about the status and the progress that acid rain has, how it has contributed to our air quality improvement since its inception. We'll also talk about the air toxics program. Now that's kind of new, and we've got a new network in place. We're doing a much better job of monitoring the ambient concentrations for toxics. It's a national standard network now, so that we'll be using common methods throughout the country. Its monitors are placed in urban and rural areas throughout the country, so you can get a better handle on how those toxics are changing. Then there are 2 other programs that we'll highlight in the report that do affect our nation's air quality. One is changes in climate. We are very concerned about any changes in climate and how those weather conditions do affect our secondary forming pollutants, such as ozone and PM2.5. So there is a program in place where we will be reviewing what some of the predicted changes in climates are and how that affect those air quality pollutants. A second issue of great concern to the United States is transport of emissions and pollutions from other countries or even across from other continents. Those are also included in the report. So to summarize, this report will show the status and trends in air quality across the country for the last 26 years. You'll see all the criteria pollutants, you'll see the toxics network, you'll see acid rain, visibility, climate change, and intercontinental transport. They're all summarized, and the status of those programs are presented in the report.
We know improvements in air quality can result in improvements in health, and school and work days lost because of health problems triggered by air pollutants can be costly. Estimating the change in health outcomes and financial benefits of air pollution control regulations can be difficult. Here's Neil Fan from the Health Impacts Division to tell us more about BenMap, a software program that can help you map those kinds of data at your desktop.
BenMap is an acronym for Environmental Benefits Mapping and Analysis Program. It's a desktop PC-based computer program that allows you to estimate the change in the number of health outcomes as a result of improvements in air quality. And the program also allows you to estimate a dollar value associated with that change. We commonly use it at EPA to estimate the monetary value of our air rules. So for example, if there's a projected change in air pollution in the future, BenMap will allow you to estimate a monetary value of that change, as well as a change in the what we call the incidence of health outcomes, so that the change in the number of, say, asthma cases, the number of premature mortalities. So it's a program that's quite comprehensive. It's also relatively easy to use, and folks that have a PC can use it at home. To run the BenMap program, first and foremost, you need to have estimated the change in air quality resulting from your policy scenario. That's the key piece of information that you need. So either changes in air quality at the monitor level or changes in air quality from an air quality model. But either way, you need to tell BenMap how the air quality is changing and where it's changing. Once you've done that, BenMap will basically do the rest for you through a series of 3 steps. After you've imported the air quality data, the next step is to actually estimate the change in health outcomes. And BenMap does that by essentially taking the incremental change in air quality and then applying a series of health impact functions. And the great thing about BenMap is that it has a very large volume or library of health impact functions available. The next step is to apply a valuation to those changes. So for instance, if you estimated that a certain number of premature mortalities were avoided, you could use valuation functions in BenMap. You could draw upon that very large library of valuation functions to then estimate a total benefit estimate. So once you've actually run a benefits analysis through BenMap, the very last step is to actually analyze the results. And you can do this in 2 ways. BenMap contains a geographic information system, or a GIS, which is just essentially a piece of mapping software. And you can map your results. You can see the geographic distribution, say, of the change in the estimated premature mortality, the change in the number of asthma cases, and you can see how that varies by geography. You can do the same thing with the valuation results. You can see how your estimated monetary value changes geographically as well. So that's a very powerful tool, and there's a variety of ways in which you can analyze the data within the GIS. You can query it. You can also export the data into other programs like ArcGIS and analyze it there. So that's quite powerful. You can also export your data in a tabular format and bring it into programs like Excel. And create bar charts, pie charts, and distribution plots. And we anticipate that the next version of BenMap that comes out is going to include more sophisticated reporting functions. So look for that in the next version. One of the very nice features that BenMap includes is something called an audit trail. And the audit trail will list in exhaustive detail all of the various options that you've selected in the program, including the air quality data you use, the health impact functions, the valuation functions, and so on. And what this enables you to do is report out in a very easy way all the various options you selected, and it will allow anyone else who wishes to replicate your analysis to do so simply on the basis of the audit trail. So it's a great way of ensuring analytical transparency and reproducibility in your analysis. So at the state, local, or tribal level, one could use BenMap to estimate the benefits of some air policy, be that a state implementation plan where you're trying to develop a way in which the state is going to come into attainment with the ozone or particulate matter standards. You could analyze a variety of state implementation plan options and see which one maximize benefits. You could also analyze various pollution control scenarios for, say, if you wanted to compare the relative benefits of applying emission controls to power plants versus cars, you could do that. I think state users would find BenMap to be particularly attractive because of how comprehensive it is and the fact that it really very much does facilitate the process of doing a benefits analysis. Before BenMap existed at EPA, we would do benefits analysis through a series of Excel spreadsheets. It was a very complicated, time-consuming process. BenMap consolidates all these functions and puts them in one place and draws upon a really very rich set of data to enable you to do the benefits analysis. You know, if you do have air quality modeling data and you want to analyze the benefits of improvements in air quality, you can do that, but you can also try and answer hypothetical questions. So for instance, if you wanted to know what the benefits of a 20% reduction in PM across the state were, you could do that without even needing to know what the emission control scenario would be or what controls you would apply. So it's also great at analyzing hypothetical questions. So in thinking about next steps for BenMap, one of the significant improvements we're going to be making to the model is we're going to be trying to make it even easier to use, and we're going to be developing a macro or wizard version. And this somewhat more simplified version will enable users to simply specify the air quality data that they wish to use to run the analysis, plug that into BenMap, and then BenMap will take care of the rest. It will apply the appropriate health impact functions, the valuation functions. It will report out the results in a very easy to access manner. And it will do all of these, it will follow this procedure that is identical to what EPA uses when it does a benefits assessment. BenMap is being used both domestically and internationally. Domestically, the Georgia Department of Natural Resources has been using BenMap for SIP planning. The state of Minnesota is using BenMap, the air agency there. The program is also being used in Oregon to estimate the value, the human health benefits, and the monetary value of a wood stove changeout program. If you're interested in actually downloading and using BenMap, you need only type in BenMap into Google and you'll find the appropriate location in the EPA webpage. On the webpage, we have both the United States version as well as the international version for download. You can do that free of charge. There's also some training materials that are posted online. There's some tutorials you can run through. There's a comprehensive user manual, which will help you understand each and every aspect of the program. There's a set of technical appendices that document every single health impact function, every single valuation function. It's quite exhaustive. So that should answer most questions for most users. If not, we also have an email link on the webpage that I believe is benmap@epa.gov, and you should feel free to email that if you have additional questions. And finally, there's a registration form, which is entirely optional, but if you do choose to provide your information, EPA will contact you periodically when there's a new version of the program available.